Hello, welcome to question 92 of this exam practice medley. So, this is nearly the end of our 93 questions medley, and this is a 10 marks question, but for part A, this is 4 marks. Now, we haven't talked about this one ever before. This is the first time perhaps you will come across using the equations or formula that you haven't used maybe previously. So we are asked to calculate the speed with which the rotor assembly turns in rotational per minute. So what have we been given? Well, we know the generator has a rotor assembly that has a torque of 30 nanometer. So torque, you're looking for a letter T to represent torque, and it's got a power. Okay, so we are focusing on this. So it's got a power. So, and the relationship of power and torque is given by the equation P is equal to torque times omega. Omega is the angular velocity. So, because we're looking for the speed in which it turns in RPM, so really we are looking for the omega. So, omega for 1 mark is to rearrange the formula, so it's P over the torque, and that gives you 56.5 times 10 to the power 3 kilowatts, because kilo is power of 3, divided by the 300 nanometer. So if you think about it, distance times force, that's actually a work done. Okay, so let's go ahead and think about what omega is. So if we first put that in the calculator, so this will give me 56.5 times 10 to the power 3, bring it down, over 300. And that comes to 188.33. And that's actually, if you don't know this by now, is radian per second. Okay, so because is asking us to put this, basically this is your angular velocity, which is your speed, so we need to change it to per minute. Okay, so so in 1 second it does so much radian, so therefore for 60 seconds, which is a minute, it does 60 lots of this. So therefore I can change omega, so that, let's do it here, omega is therefore equal to 188.33 times 60 radian per minute. Okay, so, and then if I just use this original value times that by 60, and I will get an exact value of 11300 radian per minute. However, we need revolution. Well, what's the relationship between revolution and radian? Well, back to our lesson notes. In one full circle, the turn is worth 2 pi radian. Okay, so in one full circle turn is 2 pi radian. So therefore, I will ask myself, how many of the radian, how many 2 pi is inside this number of radian? And that would means how many complete revolutions there are in that amount of radian. So to find out how many 2 pi fits in this, we use division. So therefore, if we divide 11300 divide by 2 pi, that would give us the answer in how many revolution per minute, and that's what we're trying to find out. So again, take that value we just worked out and divide by 2 pi. So that's the answer. So it turns in 1 minute that amount of turns, which sounds about right, because it's a generator, and usually if you look at the spin rate is about that quick. So 17,749. Well, actually, because it's 998, that means if I round that to 2 decimal place, that would become 00, and that actually become 50. So therefore, that's great. It should be 17750.00 rev per minute, and now I'm just going to say I round that to 2 decimal place. Okay. But actually, if you know, it will. The mark scheme would have suggested you use 17750 and just say that you round that to, say, 5 significant figure, or you can say that you have rounded to 1 decimal place, because there's too many nodes, so maybe it's not necessary to, in some cases, for it's not 2 decimal places is unnecessary. Okay, so one more thing, I forgot to put joules as sorry, what am I talking about? Is rev per minute, sorry, which I've done. Yeah, this is the unit. Sorry, it's a bit late at night, so I think I need to go to bed. Right, thank you very much.